So the first thing that we are going to discuss today is the FP growth that we have done yesterday. So when we were studying FP growth in the last class, we were trying to match the results that we have got with this one, right? So that approach is not giving the right results. I actually validated that. So we will get rid of this. So we will no more consider this conditional pattern basis and items and all that stuff. So we will go with an other approach. I'll just shortly teach you that. So that will give you the exact results. So that is called as projection based. This itself is called as FP growth, right? FP growth is nothing but it's called as projection uh, based approach. So what we basically do in this case, we project the uh, nodes onto that particular branches. We have constructed this FP tree, right? You all know how did we constructed this FP tree. Just to revise, what we have done is we constructed this FP tree, I mean the prefix tree using this shorted um, transactional data set. So in FP growth, the first step is to when you have got the data set, transactional data set, we actually have to count the frequencies in the data. So we count the frequencies of each item in the data, and once the frequencies are counted, we will actually sort the transactional data based on the counts of each item. So let's suppose if ABD is there, B has highest frequency. So we are starting from B, and then A has highest frequency, and then D has highest frequency, and then E has highest frequency. So we sorted all the items in that order, and we have created a transactional data set, right? Once this is sorted, the next step is to construct the prefix tree. How did we constructed the prefix tree? We have taken the node paths. So BADE is one path, right? So we have taken BADE and then increased the count we increased the count by 1, 1, 1, 1. And then again BADE came. So BADE count increased by 1 again. So they all become 2. So we are creating these paths BADE and BAEC. As BAEC not there, so we extended this tree to BAEC. And then BADEC. So BAD is already there. So we increase the counts of all these items and then extend it to C. And then BDC. From B, it extended to DC, BDC. So this is what we have got. This is the prefix tree, right? So the next step would be this. This is what our next step would be. Okay. The next step would be okay. So this is the prefix tree that I have taken. What I'm going to do is I'm going to create a new slide here. And in this, I'm going to add that particular prefix. So now to construct the FP trees, what we are going to do is, so this resolves the issue that we are facing error. This approach resolves the issue that we are facing error. So what we have to do now is from this tree, we want to try to find out the frequent item sets, right? That's what we are going to find out. So the first step is we know the order of the C has lowest frequency, and then AD has frequency of 5 and B has frequency of 6. So we actually sorted all of them. So now what we have to do is we have to project the tree onto different items. What does projection actually means is that's what we're going to discuss now. So C has the least frequency, right? Now we are going to project the tree onto C. What does projection actually means is that so this is the actual prefix tree, right? This is the actual prefix tree. Now, what we have to do is we are trying to find out, we are trying to project the tree onto C. So for that, what you have to do is ignore all other counts that you do have. The other counts that we do have is B, A, D, E, and C, right? So this E and C is there. So ignore all the counts. When you're projecting onto the C, ignore all the counts that you have 6, 5, 4, 4, 1, 1. Ignore all those counts. So what we are just doing is this is what we are doing. Okay, just carefully observe the things that we are doing right now. What we are going to do now is take only the counts that are relative to C. So count of C is 1, count of C is 1, and count of C is 1. Okay, we just let's just take these counts. Okay, don't bother about any other counts. When you're projecting the tree onto C, only consider the counts that um, that are related to the one that you're constructing. So after that, what you have to do is from these counts, you have to derive the counts of the other items. So that means this one propagates here, this one propagates here, this one propagates here, this one propagates here. Now there is a summation here, right? So A is combined by D and E. What are the counts of D and E? 1 and 1. So A becomes 2 and 2 plus 1 becomes 3. B is combined by the true branches. So whenever there is no branch, the same value will propagate. And if we have some branch, it will, um, gets summed up. Now we projected this tree onto C. Projection is nothing but based on the counts of C, we get the counts of all the items. Now the next step when we are doing the projection is get rid of the C now. Now remove this part and construct everything only with the remaining tree. So now as we are removing C, whatever items that we derive from this other part, whatever that we derive from this other part, at the end C will get appended. If this is something that we have derived, if this is item set that we have derived, just add C to the end of that. That is what you have to do. Now after removing C, what is our item set? What is our how does our tree look like now? The tree actually looks like this. So how does it look like? So the tree now looks like this: phi and B and A and D and E, right? So we are ignoring C because we projected onto C. So once we construct the item sets from this, we just add C to all that item sets at the end. Now look at this: E is 1, E is 1, D is 1, A is 2, okay, A is 2, D is 1, and B is 3, right? Now carefully look at the min sub. What is the min sub that we have taken? Min sub that we have taken is 3, right? So we actually constructed this. So to compare the result of the FP growth, we also have created the a priori algorithm. Using a priori algorithm, we calculated all the possible item sets. These are the possible item sets that we have got, right? For this, what is that we have taken? The min sub is taken as 3. That's the reason we just closed it. So now the min sub is taken as 3, right? Min sub is minimum support that we are trying to calculate is 3. So now calculate the counts of E. E is 2, right? So you have to ignore E. The support of E is now 2. When we projected the tree onto C, the support of E is 2. 1 plus 1 is 2. So we have to ignore that, right? So once E is ignored, we will go to D. So the tree now looks like this: phi, B, A, D, and for B we have D. So the counts of these are 1, 1, 2, 3. Okay. So now look at the counts of D. D is also appeared 2 times, which is less than min sub. So ignore that. A is also less than 2 times. Ignore that. Now the only thing that is left is B. And the min sub of B is 3, which is greater than or equal to 3. So only we have to consider B. Now the conclusion is that when this tree is projected onto C, we got only one item set, which is B. For this item set, we have to add C at the end. That's what I'm saying, right? When we are projecting the tree onto C, we just have to add that C to the B. So BC would become the item set, valid item set. And the support of this BC will be 3 because the support of B is 3. Whatever the support of B is, the same support will carry for the BC as well. So this is one of the item set that has got derived. Okay. Now that is done. The second thing is, as this is the first step, we projected onto C. The second step is project onto E now. Okay. Now we have to project the same tree onto E. We need to continue. We need to keep on projecting the tree onto different items that are available in this particular tree set. Now, again, if I have to project onto the C, now C is done. We have to ignore C. Now, when I project this tree onto E, the tree actually looks like this. How does it looks like? B, A, D, E, and then A comes to E, B comes to D. Okay. Now, what we have to take? Only we have to take the counts of E, right? Right. So we just have to take the counts of E only. Whatever the counts that are there in the prefix tree, the same counts has to be taken for the tree which is, projected onto E. So the count of E in the prefix tree is 4. So I'll take the 4. The count of E in the prefix tree is 1. So we take 1. Now we got 4 and 1, right? Now we got 4 and 1. Okay. So we got 4 and 1 here. So E is 4 and E is 1. Now now the counts of the remaining stuffs will be calculated from the you know from these counts. But we, as this branch, BDC branch, right? As BDC branch is not there, so projecting onto E is nothing but only project onto the branches where E is present. Okay. Here there is no E. In this particular row, there is no E, right? So we don't need to project this branch. I mean, we don't need to consider this branch when we are projecting the tree onto E. But when this is how it looks like when I project the prefix tree onto this particular branch. So how does that it is looking like? So the count of E is 4, count of E is 1. So 4 propagates here and 4 plus 1 becomes 5 here and 5 propagates to B. Okay. Now remove the E now. As the second step, remove the E. So whatever comes, we just append the E to the end of that. That's how you have done. That's how you have done here, right? So now what do you have? You have B, A, and D, right? That is how you have. So this is 4, this is 5, and this is 5. Okay. Now, whenever you get the items in a straight line, so what are the possibilities? B, A, D is possible. So you can come, you have to derive everything that is possible from this. Now, when you got a straight line, what you have to do is when all of the supports are valid and the min support is more than all of them, what you just have to do is you have to combine all of them and derive the possible combinations out of those items. So what are the possible combinations from this BAD? They are B, A, D. These are one item sets that are possible from those combinations. The other one is BA, BD, AD. So these are two possible combinations that are coming up. And the third one is BAD. Okay. So at the end of everything, we just have to add E, right? That is what you have to do. At the end of everything, you just have to add E. So I'm adding E to every item set. BA, AE, DE, BAE, BAE, BDE, ADE, BADE. And what are the supports of this? Supports of this is nothing but the support of that item at that, in that branch. So it is B5. For A, it is 5. For D, it is 4. For BA, it is 5. For BD, it is 4. Because just consider the last one. You have to write the items in the same order, how they are appearing here. Like A comes after D, D comes after B. Okay. You shouldn't write DB. You should write it as BD. Then only you'll get the right support. You have to write in the same order. And now, then comes AD. What is the support of D? Which is 4. BADE support would be 4. Okay. So that is how you have to derive. So these are all valid item sets. We can compare these item sets later by comparing the results of the approach algorithm. These are the results that we have got, right? We can compare the results. But let's complete everything that we are getting right now. And then we can conclude, we can validate the results. So the next step would be to project onto D, right? So we have projected onto C, we have projected onto E, and we have got some item sets. The next step would be to project onto the D. The tree has to be projected onto the D now. So for that, what do we have to do? We have to again project this tree onto D now, where we projected onto C and E. Now we are going to project onto E. So that's what I'm going to do now. Let me add a quick slide here to show you that. So adding a blank slide. And then I'm going back here, adding this here. Oh, let me go back. Okay. So this is the prefix tree. So I don't want to go back and see the value. So I'm just pasting it here. Now the next step is to project onto D, right? Pointer options, go to D color, and now you have to do this. So now this looks like this: pi, B, A, and D, right? So now when you're projecting onto D, this is the possible prefix tree. Now projecting onto D. So what are the counts for D and E? 4 and 1, right? So A carries 4 and B carries 5. 4 plus 1 would be 5. So this is the prefix tree. Now get rid of D because we are projecting onto D. So now the tree that is coming up is B and A, right? Support with 4 and 5. Now we got two items, B, A. What are the possible combinations that we can generate from this? It is B, A, and B, A. What you have to do at the end, just append D to every possible combination, right? So now we are appending D to every possible combination. So this becomes PD, this becomes AD, and this becomes PAD. What is the support of this? Support of BD is 5 because support of B is 5, support of A is 4, support of BAD is 4. Okay, these are the three items that we have got for when we projected the tree onto D. And the next thing is projecting the D is done. Now project the tree onto A, right? We project the tree onto A now. So once the tree is projected onto A, what we will get? We will get a simple line. It is B and A. What is the project? What is the? I mean, when it is projected onto A is 5. In the prefix tree, the count of A is 5. So the same will be carried to the B as well. So ignore B, ignore A. So the only possible thing that is available is B. And the support of that is 5, which is greater than the min support. So just append A to it at the end. So we are appending A to the A to B. So this is a valid item set, frequent item set, and the support of this is 5 because support of B is A. And the only thing that is left over is projecting onto B, and this will be the C. So there are no possible combinations with B. That becomes a null set. Now what all we have got? We have got some set of items, right? Now let's compare this result with the a priori result that we have got. Okay, let me take all of them into a single slide. So you will actually understand we can actually compare the result. So what are the things that we have got? So this is one set that we have got with different support values. Okay, so this is one thing that we have got. Let me add a new slide at the end where we will compare all the results. So this is one of the result that we have got for FP growth algorithm solving. And what is the other result that we have got? This is one thing that we have got, right? This is one thing that we have got. Just copy that and go back here. Where is that? And paste it here. That is one part. The third part is what is the other one that we have got? We have got BA 5, right? We got BA as 5, and we have got other one which is BC. Okay, we got BA, we got BA, and we also have got BC with support 3, right? We also have got BC with support 3. This is all what we have got. Okay, this is all what we have got, and this is the result that we have got from the a priori algorithm. Now we have to compare both the results and make sure we have got both the results equal, right? That is what we have to. We actually tried to solve that by this, right? Okay, so this is what we have got from a priori algorithm. Now let's compare and find out if you have got everything or not in this. So we got AB, right? Which is 5. So AB is there. Let's cancel everything so that it will be cleared. Okay, we got AB as 5. AB, where is AB? Yeah, here it is. So we got this AB. So this got matched, and AD4 matched, AE5 matched, BC3 matched, BD5 matched, BE5 matched, DE4 matched, ABD4, ABD4 matched, ABE5 matched, ADE4 matched, BDE4 matched, BADE4 matched. Okay, so now we got the right result. So how did we achieve? It's the projection. Constructing up to prefix tree. Now we have, if you want to project onto C, you have to ignore the counts of all other item sets except C. So take only the counts of C from the prefix tree for the tree onto which you are projecting. So you got the counts of C as 1, 1, 1. So it propagates until unless it has a branch, the same value will propagate. Whenever it has a branch, you just have to append both of them and add all of them and get the value of 2. Now 2 and 3 is compared and you get 3. Okay. So that is how you got the projection. And now you remove all the C's and to the result, to the item set that you're getting, just add C at the end. Now you know E is not, you know, E is not uh, frequent because its frequency is less than the minimum support. D is not frequent and because its frequency is less than minimum support. A is not frequent because its frequency is less than minimum support. But B is frequent. Okay. B has support 3. Now append B to C so that we are getting the support as 3. The second one is projecting onto E. When we project the values onto E, what we have done, you have to take only the counts of E and ignore the E's. And BAD we have got, so the count of D is 4, A is 5 and B is 5, right? D is, when you get the straight line, you take all those values when they all have minimum support, I mean support greater than minimum support, they are all frequent. So now generate all the possible combinations that are coming up from BAD. The possible combinations for BAD is BAD, that is one combination, and two combinations, BA, AD, and BD. Okay, these are two possible combinations, and the third one is BAD, three possible combinations, and append E to the end of everything. Okay, we appended E to and E to the end of everything. So the support of this will be coming from this trees. Okay, the support of this will be coming from the main tree, which is if you look at this, the support of B is 5, support of A is 5, support of D is 4. BA, when arranged in the same sequence of the tree, the last letter support would be the support of that entire item set. BA, A comes the last, so 5 is the support. BD, D comes last. Support of D is 4, so support of the whole function is 4. AD is 4, BADE is 4. Okay, that is how you're going to get the support of all of I mean all the frequent item sets by projecting onto E. The similar way you projected onto D, took the count of D's and get the values of other item sets from those counts, and remove that D and see if you're getting a straight line. So if you're getting a straight line, derive all the possible combinations from those two things. BA. Possible combinations are BA and BA. One item sets and two item sets. Just append D to everything so that you will get the real item sets. And finally projecting onto A and you got BA. There is nothing to project onto B because on top of it there is just pi. That is how you solve the FP growth problems. Okay, don't forget about that conditional tree bases and conditional FP trees. So that is not giving the right result. This is the right approach of doing that stuff and easiest way of doing that stuff. Okay, that is what it is. And let's go back understand what is non-derivable item sets. So this is what we are discussing about, right? I'll just give a quick recap of this so that you will just try to understand. I mean, you will get an understanding of it. So what is called as non-derivable item set? Any item set whose support cannot be derived from its subsets, from the supports of its subsets. Okay, such items are called as non-derivable item sets. So it makes sense, right? When you are not able to derive the support of an item set from its subsets, it is meaningful to actually store them and use them later, right? Instead of calculating them. When you know it can be derived from the values of its subsets, there is no point of storing that. We can derive them. Okay. So that is what non-derivable item sets means. And I also have shown you a transactional space with three different items and their respective transactions, right? This is the transactional base, and this is item A, this is item B, and this is item C. And item A happened 5 times. Item B alone happened 2 times. Item 3 alone happened 3 times. When you see this intersection range, when you look at this intersection, that specifies how many times A and C occurred together in the basket. That means you have A and C in your basket, right? That is what it means. But you don't have B in it. This part, right? This part indicates just A and C. Okay. This part indicates only A and C. when you take this whole part, it includes A, B, and C together, right? It has A in it, it has C in it, it has B in it. Okay. So if you only consider this part is, what is this? A, B bar, C, right? So in real world, you don't have these negotiations. So what you have to do, you have to get rid of these negotiations, right? How do you do that? You use inclusive and exclusive method, right? So whenever you have a negative term in your item set, what you have done, you have separated that positive terms and negative terms, right? A became forward and B dash C dash has to be separated on the other side. Now you have to use the lattice structure and you have to start from the positive item set and you have to reach to the level of the complete item set, which is ABC. So now to construct that, what you have to do, you have to start from A, traverse to the end of ABC, which is the compliant complete term without the negotiations. So give the positive sign for the positive term and then negative and the positive. So level by level, you will keep them as positive and negatives. Okay. And now you have to write the term like this. S of A, B bar, C bar is equal to S of S, support of A, and it has plus. And for the next level, it is minus. So minus S of AB minus S of AC plus S of ABC. Okay, that's what you have got. S of A, B bar, C bar is equal to S of A minus S of AB minus S of AC plus S of ABC. Right? That is what you have got. And the same thing we have verified intuitively. We have derived this from this item set and we have got both of them equal. So simplest method is to just go with inclusion and exclusion principle. So now we represented a specific part in the transactional space in terms of which has negotiations. In terms of Venn diagrams, it has negotiations, but we converted that into all positive terms, right? Support of A, support of AB, support of AC, support of ABC. How do you calculate support of ABC? You go to the entire transaction space and see where, in which all transactions that ABC is happened, ABC together happened, and that count would be the support of ABC. So it's till this point, we just have discussed how to convert the negative terms in your support calculations. Item negative doesn't make sense. So we want to convert them to positive terms, right? So we have done that, right? So that is what I have explained here. I formulated that into this one. So what happened? J minus X. Okay. Um, J is this changing term, right? J is changing term. X is ABC. From what we are trying to find out, we are trying to find out ABC, right? So we subtract everything from ABC and then we get the remaining term would be the negative term. So here is 1, 3 minus 1, 2, 2 minus 1, 1. So the second terms it becomes negative, first terms it becomes positive, and the third terms it becomes positive because 3 minus 3 is equal to 0. J is ABC, X is also ABC, and then that becomes, um, negative term of it. That becomes, for the odd levels, 1, 3 odd levels, it is becoming positive, and for the other terms, it is becoming negative. Simplest way is just to draw the lattice diagram, and you can do that. Now, the final part is understanding how to find out a support, a particular item set is bounded or not. Okay, that is what we are going to do now. Let us go do that and understand what is which item is non-derivable and which item is derivable. So that is what we are going to study now. It doesn't take much time, very few minutes. You're almost there. Just a second. Now, when you say non-derivable item set, you know for any item, if we are not able to calculate the support from its subsets, we call that as non-derivable item set. That means support is bounded. Okay. That means I'll explain you this way. So let's suppose I would say, let's suppose, let me put the statement forward and then we can derive that. So for a non-derivable item set, support will not be constant. Support cannot be calculated, but we can specify we can calculate the bounds of it. I mean, the lower bound of it and the upper bound of it. For example, what are the bounds means? For example, if there is an item set A, if this is non-derivable, but we can derive the bounds of this item set. That means if the support of this, actual support of this is 3, if you're not able to derive this, but we can derive the bounds of it. That means the support of A is greater than 2, but less than 4. This is what we can derive for that, non-derivable item set. Okay, if the lower bound and upper bound of an item set is equal, okay, let's suppose when I'm deriving the lower bounds and upper bounds of A, if both lower bound and upper bound became equal, okay, then A is derivable. I can say A is derivable because we derived a single value for this item set, right? So that means when we are coming up with a single value, that means we are able to derive the value of it. Okay. When that happens, when we are calculating the lower bound of A and upper bound of A, when both are becoming equal, that means you're coming down to one value. When it has something like this, when the lower bound is not equal to upper bound, you're not coming up with single value. There are so many possibilities, which is 2, 3, and 4, right? There are different possibilities. So we're not able to derive a single value for this item set. But when you're able to come up with single value, when does this gets a single value? When lower bound and upper bounds are equal at some point. At that time, you're getting a single value. So such kind of item sets are called as derivable. So you will know how to calculate. I mean, shortly we will discuss about calculating the lower bounds and upper bounds. But this is what you have to understand. When lower bound and upper bound are not equal, you can say that is not a derivable because you're not coming up with single value. But when lower bound and upper bounds are equal, that means you're coming up with a single value for that as a support for that item set. So that would be an, derivable item set. That is what I mean to say. Now let's see how to calculate the upper bounds and lower bounds for that particular, for a particular item set given. Let's take the same example. Let's take A, B bar, C bar that we have done so far, right? So what is the positive part in it and what is the negative part in it? B and C is negative and A is positive, right? Let's quickly construct the lattice for this. So A, B, C, right? So A, B, C. Now it comes A, B, A, C. And finally, both of them converges to A, B, C, right? So this is the tree set. Now let's calculate, let's point out everything. So this is what it is. Now this is plus, this is negative, and this is minus. Okay. Let's come up this. So as I discussed, this takes positive, this takes negative, this positive. So we always start with the positive term, go to the negative term, and just change the plus and minus symbols. Okay. So now if you say this is how you do. Support of A minus support of AB minus support of AC plus support of ABC. Okay. Right. So this is what we have got so far, right? And now I'm adding some other terminologies to it. That is just for simple bound calculations. Just remember that, for the bound calculations, support will always be greater than or equal to zero, right? Support cannot be negative. Do you agree with that? Support will always be greater than or equal to 0. When do we get support as 0? When you don't have that item in any of the transactions in the transactional database, right? So I can say support of anything will always be greater than or equal to 0. S of A, S of AB, minus S of AC plus S of ABC. That's we have got, right? So this is a support of A, B bar, C bar. So this will be always greater than or equal to 0, right? So now what I can come up with this is support of ABC is greater than or equal to minus support of A plus support of AB plus support of AC. Okay. So that is the value of support of S of ABC will always be greater than or equal to minus SA plus S of AB plus S of ABC plus S of AC, right? So this is the lower bound of ABC. Okay. So this is the lower bound of this of that one. Now, if I have to calculate the upper bound of this, how do I calculate that is it's this one. So let me take this way: A bar, B bar, C bar. Okay. So there is a simpler way to actually get the upper bounds and lower bounds. I'll just show that to you shortly. But this is an normal, I mean, um, what do we say? Venn diagram approach. So if I come up with A bar, B bar, C bar, there is no positive term in this. So what you have to do is you have to start from pi. Pi is nothing but there is nothing. And then A, B, C. This comes A, B, A, C, right? And then A, B, C. So what is your interest now? Your interest is always lying uh, between this and this, right? So now how you are getting from here to here? You're reaching through everything of this, right? So AB is combined, AC is combined, and then ABC is combined. So now you're going through all the rows from here to here you're going. So this comes positive, this comes negative, this comes positive, and this comes negative. How do you write it? This is written as something like this: S of pi minus, for all these terms you have minus, S of A minus S of B minus S of C, and then positive terms, which becomes S of AB plus S of AC. Okay. And then we got minus term, which is minus S of ABC, right? That is what we are actually getting everything. So S of pi, this is S of pi plus and minus S of A minus S of B minus S of C. We got all of them as negatives. And next comes positive S of AB, S of AC. And then comes S of ABC, which is minus. Okay. So that is how we got, that's how we derive S of ABC now. Now, if you look at this, again, this is greater than or equal to 0, right? So this is greater than or equal to 0, right? Any support is always greater than or equal to 0. Now, if I move everything onto the other side, or else just move this minus SAB to the other side. So that becomes S of ABC is less than or equal to. So this is going on this side. Minus becomes positive when it goes that side. So write everything on the left hand side now. S of pi minus S of A minus S of B minus S of C plus S of AB plus S of AC, right? So that is how you have written everything. Okay. S of A minus S of C minus. Now just look at how this is happening now. You have found upper bounds and lower bounds. So S of ABC is less than or equal to S of ABC is greater than or equal to. So this is called as lower bound, right? Lower bound of this. For S of ABC, for ABC, lower bound is this. This is upper bound because S of ABC is less than or equal to. So on this side, it will become upper bound. If as it is on the less, S of ABC is greater than here. That means it falls here somewhere like this. S of ABC is greater than or equal to this value, less than or equal to this value. So this becomes lower bound and this becomes upper bound. Whenever lower bound is equal to upper bound, we call that as derivable. Okay. Whenever lower bound is not equal to upper bound, we call that as non-derivable item set. When both are equal, we call it as derivable item set. When both are not equal, we call that as non-derivable item set. Okay. So that is the calculation. Now, if you carefully look at the way that we have derived, how did we came up to this? S of ABC, right? S of ABC. We started from here, right? From this to, from started from this to this. That means, uh, let me just go to the next slide and show you how to actually find out. Now our focus is, this is looking like a tedious task, deriving, taking these values and subtracting everything. But I'll just impend the greater thans and negatives into the same chatter plot. And now you will understand how to calculate the lower bounds and upper bounds of a particular item set that is given. Okay. Now let's suppose if you are given with if you're asked to find out a given item set is non-derivable or not. Okay. So now you're given like this. So you're now when lower bound is not equal to upper bound, such kind of item sets are called as non-derivable item sets. If lower bound is equal to upper bound, such kind of item sets are called as derivable item sets. Now you're given with this. Now you're asked to find out. Now you're asked to uh, find out whether an item set is derivable or not. That is what you're trying to find out now. So let's take an example and then and also an item set. So this is the final 10 minutes of session. So you will just get this is the last thing of item set mining. So with this you will be done from starting next week. We will start the classification. Classification basically means saying whether a given image is dog or not. Let's suppose you have some data sets. You created a model from the data set. Now given an image for you, you're given a dog image. You have to say whether that is dog or not. Even if a cat is given to you, you have to say that's not dog. As dog or not dog, that's what you cannot say that is cat or something like that. So you can even say that when you have multi-class. So actually that is the concept that we're going to try from next week. It's called as classification. For now, let's wind up this. Don't go there. Right. Now, this is the example for you to understand to find out whether a given item set is derivable or not. Okay. Now we got non-derivable item set. This is what we are trying to find out. Okay. Now, given something like ABD is derivable or not, this is what you have to find out. Okay. ABD is derivable or not is what you have to find out. Okay. So now you're given with some data set as well. Let's take the data set as this. ABD. ABD is first transaction. BC is second transaction. ABD is third transaction. ABD is third transaction. Fourth. ABC is fourth transaction. ABC. ABCDE. ABCDE is fifth transaction. Sixth is PCT. This is the sixth transaction. I'm taking an example of the transactional database, and we have got an item set which is ABD. Now we have to find out ABD is derivable, non-derivable item set or not. Okay, that's what we're going to find out. So what we quickly do is let's quickly draw an lattice structure for this particular diagram. So how do we write the lattice? How do we create the lattice for this? Uh, you all know how do we create lattice for this, right? So take pi and then comes A, B, C, D, E. And what are the supports of A? Support of A is 3, 4. Let's take the min support as 3 for this. Min support is 3. Min support is given as 3 for this. Okay. So for A, it is 4, right? For what is the support of B? 6 is the support of B. What is the support of C? Support of C. 4. Support of D is 4. Support of E is 5. Right? Support of C is 4. Support of D is 4. Support of B is 6. Support of A is 4 and all that stuff. So we got everything. Now, let's go back to AB. Okay. Let's go back to the second level. That becomes AB, AC, AD, AE, BC, BD, BE, CD, and CE. That's what we got, right? Should I have extended this? But okay. We have got CD, CE, and DE, right? We will get CD, CE, and DE. We got CE and DE. These are the possible things, right? Now keep on doing that stuff. Okay. Now let's keep on doing that stuff. So next comes ABC and next comes ABD. Okay. So this is how we derive the item sets. Now I don't want to extend further. Okay. You can actually calculate the supports of every item set, and you also will be calculate what is the support of each item set that is given here. But for now, I'm giving the results for you. What does the results means is I did actually calculated everything for this, and now I'll put the result for you. What are the frequent item sets and what is the support of them? Okay, this is what my calculation is. Support of 6 is for B. B has support of 6. 5 is also item sets with frequency 5 or support of 5 is E and B. These are all frequent item sets. And for 4, the items that we have got is A, C, D, A, B, A, E, B, C, B, D, A, B, E. Okay, so these are the item sets with support of 4. And now support of 3, A, D, C, E, D, E, A, B, D, A, B, D, A, D, E, B, C, E, B, D, E, A, B, D, E. Okay, this is my this is what I have calculated. Even if you create the lattice structure and if you just do a priori algorithm or something, you'll get the same result. It's up to you whether you use a priori, eclat, or FP growth. Whatever approach that you follow, you will be able to get the same results. Now our main intention is not to find out the supports of the frequent item sets. Okay, our main intention is here is to learn whether a given item set is, non-derivable or not. For that, what you have to do is, again, you have to find out, you know the item set that is involved with ABD. Okay, ABD is actually derived from these three things, right? So it involves ABD, and then from ABD we got AB and AD, and then you got ABD, right? So I'm doing it in reverse order. From pi, we have to have A, B, and D. Now, when A is combined with B, it got AB. When A is combined with D, we got AD. And finally, we got ABD, right? This is how we got it. Okay. Now, what you have to do is when you're finding out the lower bounds and upper bounds, this is what you have to bring out from this lattice structure. Once this is brought out, you just have to blindly do this. So you just append greater than or equal to for this, less than or equal to for this, greater than or equal to for this, and less than or equal to for this. Starting with greater than or equal to 0, you just have to keep on doing less than or equal to, greater than or equal to starting, less than or equal to. And I'm adding 0 here, plus, minus, and plus. Okay, the same way. What you have done earlier when you're trying to convert a negative item sets into positive item sets, you started from the positive item term and you have gone to the complete term, and you have given plus for the first one and negative and plus. For finding out, you know, uh, for finding out lower and upper bounds, this is how you have to do it: greater than or equal to 0, less than or equal to 0. So why we are doing greater than or equal to 0 and less than or equal to 0? So this is the actual way. From this, you have actually derived this. So how did we derive this? So let's suppose here we are trying to find out ABC, right? So look at this. What we have done, you have given, um, where is that? You have given plus for this, right? So you're trying to find out greater than or equal to for this. So look at this: plus, minus, plus. Okay. So that became plus, minus, plus. For the first one, we are trying to find out for this particular item set, right? So for that, we are given greater than or negative, less than or equal to greater than or equal to 0 if we are starting this step. So even if you carefully observe this, that here also we have done the same thing. Plus or, from where we have started, we are trying to find out for ABC, right? So we just written this in reverse order, right? We have written this in reverse order from pi to ABC. we have written greater than or equal to 0 for this, and then you have appended everything. So you have started from greater than or equal to 0 is something covered in this screen, right? Sorry, I think I just have to put it here. So where this is the term greater than or equal to 0, from this we have started, and we are from here we are going till the positive ones. Look at this, we are going in the positive terms. We have given negative for the second one, right? I mean, from where we are trying to find out. When you're actually derived this, when it came to the other side, when you actually came to the other side, positives are coming from this, double one sides. Negative came for this, positive came for this. So from this, it is actually derived. This, even from in future, you can just derive this. When you forget this, you have to go back to that. But let me write this now. You can derive multiple rules from this. What is the rule one? Rule one should be derived from this first row. Okay, that is S of ABD is greater than or equal to 0. That is rule 1. I'm also writing left hand side and right hand side. What is the support of ABD now? Support of ABD is, where is that? Support of ABD is 3. So on left hand side I have 3, on the right hand side I have 0. Support of on the right side is greater than or equal to 0, so it becomes 0. Now I'll derive the second rule. What is second rule? Second rule is S of ABD is less than or equal to, look at this, is less than or equal to S of AB. Okay, that is second rule. So we traverse from this to this. Okay, now we're creating rule only till this part. Okay, that is what it is. ABD is also derived from BD also. BD also comes here. Okay, AB, AD and BD, all of them will be the subset of these things. Okay, right? So because just this BD also should come here. So BD is also part of ABD. We are not coming backwards, right? So, but BD is also part of ABD. So AB, AD and BD, all of these things will be part of ABD. So I just missed ABD. So BD also comes there. So BD also comes here because ABD is actually derived from BD also. So BD also comes here, and the support would be less than or equal to. So it would be less than or equal to. Okay. So I'm coming back to the second level. So ABD is less than or equal to S of AB. Third rule would be S of ABD is less than or equal to S of AD. And fourth, this is third rule. And the fourth rule is S of ABD is less than or equal to S of BD. Okay, I have derived 4 rules now. Rules are derived just like this. We started from the first level, and from the first level, we are coming down to the second level. And in the second, when you're coming to the second level, it comes less than or equal to S of ABD is less than or equal to AD. S of ABD is less than or equal to BD. And now for rule 5, where we are going, we are coming back to E. When you're coming to A, I mean one item set level, how does it is? Now you have to write like this: S of ABD is greater than or equal to here. So look at this, in the third level, we have got greater than or equal to. Now what you have to do, you have to sum up everything in that particular way. So how did we arrive at A? We arrived at A in this angle, right? We arrived at A. How does A reach to ABD? From A, we derived AB and AD. A is not part of BD. It is part of only AB and AD. From AB and AD, we got ADT. So that is the path, right? So when you're writing rule 5 for A, this is how you have to write. Minus S of A. Because in this level, we have minus. In this level, these two are involved and those two have plus sign. So you have to write plus S of AB plus S of AD. So that is one of the rules derived for rule 5 derived from A. And now I have to derive rule 6. Rule 6 is for B, right? B is part of AB and BD, not AD, right? So again, greater than or equal to. So S of ABD is greater than or equal to, S of ABD is greater than or equal to minus S of B, because only B is involved. Now the new thing is these three are involved for B, right? ABD, AB, BD, B are involved. So minus S of B in this level, what are all there? Plus AB and plus BD, plus S of AB plus S of BD is there. Okay. Why we have given greater than or equal to 0? Usually this comes minus S of ABD, right? Minus plus minus. This becomes minus S of ABD. When this goes to the other side, this becomes plus. Okay. That is what it is. When you write for this, what becomes S of AB minus S of ABD less than or equal to 0. So S of ABD, when it goes to the other side, this becomes positive. So this actually looks like S of AB minus S of ABD is what that comes for here, ABD2. When you start with positive here, when you end at negative here, that becomes S of AB minus S of ABD. When it goes to the other side, this becomes greater than, right? Uh, Did you understand? Here, when you start from the positive term and go to the end term, how does look like? S of AB minus S of ABD is greater than or equal to 0, right? Because we start with plus and go on to the end with negative signs. So now what this becomes, when this goes to the other side, S of AB is greater than S of ABD is what it happens. But when it comes to the third level, this comes with positive minus plus, right? So when plus, all other terms will go on to the negative side. So for these items, we got negative and these items, we got positive. Are you getting me? So this is the same topic, like we start with plus and go to the negative. But instead of writing all of the support and greater than 0, I'm using these symbols. Okay. I'll also show you at the end why that actually means is. Okay. So minus S of B plus S of AB plus S of BD. Only two terms are there. Now, if I construct the same using normal terms, remove all of them. Now we want to reach from, we have the positive term as B. From B, we want to reach to ABD. How do we write? Normally, give plus to B and minus to the next terms and plus to the last term. So how do you write that? You write that this way, right? Support of B, you will write it this way. How do you write that? You will write it this way. Something like S of B minus S of AB minus S of AD plus S of ABD. This is what you will write when you want to find the support of S of B, A bar, D bar. Okay. So to find out ABD, negotiations will not carry. This is derived for ABD only. There are no negative negotiation terms in the real world. Negotiation terms comes only when you deal with negative terms. Now look at this. Is any support is greater than or equal to 0? So all these terms will go to the other side. S of B, S of minus AB, all these terms goes to the other side. So this becomes S of ABD is greater than or equal to minus S of B plus S of AB plus S of AD. That is what we are coming up. So to simplify, to not think all of that, we have just created this. Okay, greater than negative alternatively. That is what actually happens in the real calculation as well. When you do more, you will easily apply this. Okay. So when you want to find out for ABD, start with ABD, go to pi. For the first ABD, you have to give greater than or equal to. From there, you have to give less than or equal to alternatively, greater than or equal to, less than or equal to, greater than or equal to, and less than or equal to. And you just append, give 0 to the first one and then positive, negative, and positive. So you will get the right results. And now the rule 7 says, what does rule 7 it gives us to you? Now only left is D, right? Now left is D and pi. So we have to get two more rules. So the two more rules would be, I'm quickly writing this. And once the rules are written, you can actually calculate the upper bounds and lower bounds. So greater than reckon are basically upper bounds and lower bounds only that specifies. So now I'm writing for D. That means S of ABD is greater than or equal to minus S of D plus S of AD plus S of BD. Okay. S of AD plus S of PD minus S of D plus S of AD plus S of PD. Okay. That is what rule 7 is. What does rule 8 says? Rule 8 says S of ABD is less than or equal to S of ABD is less than or equal to S of pi minus S of A minus S of P minus S of C. Okay. Negative is given for all of them, plus S of AB plus S of AD plus S of BD. Okay. And then comes minus ABD, right? Then comes, what is it? I mean, ABD is already given, only to this level we are going. So that would be the eighth rule. Okay, that's how you construct the rules. Once the rules are constructed, now you can easily calculate the left and right hand side supports. Now get this. So support of ABD is 3, right hand is 0. Now support of ABD is 3. What is the support of AB? Support of AB is 4. So left becomes 4. Okay, so the left became 4, right? S of AB is 4 only, right? Right. So left is 3, right is 4. And what about ABD? Left is 3. And what about AD? AD. Sorry. Something is wrong. So what is left hand side here? Left hand side is 3, right hand side is 4. When comes here, 3 is okay. Uh, Look at this. What is that we have given X, H, right? This is upper bound and this is lower bound. This is ABC. Okay, we are trying to find out the lower bound and upper bound. When X is greater than or equal to 0, that means what is the LHS here? What is the support of 3 is greater than or equal to left hand side. So initially this becomes 0, right? So let's understand this notation. So initially S of ABD's lower bound is 0. You don't have upper bound from the first rule. This is from the first rule. From the first rule, lower bound, we got the lower bound of ABD, which is 0. From here, what is the upper bound of ABD? This is the upper bound because it is less than or equal to AB. AB has support of 4. So now the upper bound of LBD is 4. Lower bound still remains 0, right? This is from the second rule. From the third rule, again it is less than or equal to AD, right? So AD, what is the support of AD? AD support is 3. So this again becomes upper bound, right? Lower bound still remains 0. And what about this fourth one? What about the fourth one? For this BD, what is the support of BD? 4, right? That is upper bound only. Lower bound still remains 0. So the upper bound and lower bound will be 0 and 4 now. Go to the rule 5. Rule 5 says S of ABD is greater than or equal to. So this becomes lower bound now, right? Greater than or equal to means the left hand, this would be the lower bound. Less than or equal to means this would be the upper bound. So this would be the lower bound. So to calculate the support of this, support of A is 4 plus S of AB. AB support is 4. Something we have written wrong here. For ABD, it is AD, right? AD, AB and AD for ABD. For ABD, we have written this for A. So that comes minus AB plus this is AD. We have got it for A, right? Got it for A. So it involves A and AB and AD. So that goes to AD. Okay. So now if I go back here and write the stuff, what is the support of AD? Support of AD is 3. So support, now the lower bound is becoming 3, right? Lower bound became 3 and upper bound is 4, right? That is what we have got. And going back to the next rule. And again, this is also lower bound. This is also lower bound. Calculate the lower bound of this. S of D minus 4 plus S of AD is 3. S of AD is 3 plus BD. What is BD? 4. So now the lower bound is again 3. Upper bound is 4. And now calculate for the ABD. S of pi is, how many items are there? So that will be the support of S of pi. We have 5 items, right? How many items we have? 6 items or 5 items? A, B, C, D, E. 5 items. 5 is the support of pi minus S of A is 4 minus S of B is 5 minus S of C is 4 plus S of AB is 4 plus S of AD is 3 plus S of BD. S of BD is 4. Right? We got this. Cancel these two. Cancel these two. Cancel these two. Now we got the lower bound as 3, upper bound as 3. S of ABD is less than or equal to, right? So this becomes upper bound. So now lower bound became equal to upper bound, right? So when both are equal, you say ABD is derivable. If not, ABD is not derivable. So that is how you actually derive the rules. Again, I am repeating. So when you are asked to find out the given an item set is you know uh, what is that is derivable or not, you just have to construct this diagram. This is the more important thing from which you will construct the uh, what is that you will construct all the rules possible. So now look at you when you have three item sets, the possible rule sets will be 2 to the power of 3, which is 8. 2 to the power of n. If you have n item sets in the item that you want to derive, here you have 3 items. When you have n items, you will get 2 to the power of n number of rules. Here there are 3 items, so we got 8 rules. So what you have to do, start from that item and go to pi all the way to pi. So just connect all the dots possible to ABD. So here ABD is possible. From this we got AB, and from this we got AD, and from this we got BD, and all of them will be coming down to BD. So start with greater than or equal to 0, less than or equal to 0, greater than or equal to 0, less than or equal to 0. So this will be 0 plus minus plus. Now start from ABD. This would be the first rule. ABD is greater than or equal to 0, first rule. And then come to AB, second rule. Come to AD, third rule, fourth rule. And then all the way to A. All possible items till A. Okay. All possible items still A would be the next rule. So all possible items till A would be the next rule. All possible items till B. So B involves all the items, right? So D is not involved in this. So all this will come here. That would be the next rule. D involved. So these will be the D involved. Okay. So that's how you derive all the rules and calculate the upper bounds and lower bounds by using the suppose that we have calculated from that for the transaction data set using a priori or any other algorithm. Whenever you have left and right equal, you have to calculate lower bounds and upper bounds from all the rules. And at any time when you got lower bound and upper bound equal to are equal, you say that as non-derivable or else it is derivable. Okay. So that is all about non-derivable item sets. Okay. And I told you that I'll talk about normal distribution in higher dimensions. I'm not going to provide any the derivations, but I'll just give the statement for you just to remember. But that is not actually useful anyways in the real world, just for your understanding why we need to do the dimensionality reduction or all the and all that stuff. So just remember this, in higher dimensions, we have seen many things like the distance between the points doesn't make any sense in higher dimensions. Most of the points lies on the surface, right? Those are all things that we have studied. So most of the area or most of the volume will be concentrated around the surface. So we have learned all those things in the higher dimensional classes. But I want to make a statement about normal distribution because that is how most of the data in the real world will be falling down to. Most of them will be normal distributed. You also have seen central limit theorem, right? So what does central limit theorem says? Take any kind of distribution. If you take the means of the distribution and if you form a sample, that will be normally distributed. Okay. Sample means forms normal distribution. That is what central limit theorem says. And now look at, remember the statement in normal dimensions in 2D or 3D, this is how it looks like, right? The normal distribution usually looks like this. You already know that principle. What is that principle? 3 sigma's principle, 68, 95, 99.7%, right? You remember that rule as well. So that is all valid in lower dimensions. When you go to upper dimensions, the diagram doesn't looks like this. In upper dimensions, in higher dimensions, the diagram actually looks like this. How does that looks like? It looks like this. So in higher dimensions, it would be a small blip here and something like this. What does that means? It is a small blip means not so many points lies here. This is the probability density function, right? It's not so many point lies here. Most of the points lies in the tail region. Okay. That is how the normal distribution in higher dimensions will be. Whereas in contradictory in the lower dimensions, most of the data points, 99.7% of the data points lies within three standard deviations. That is what three sigmas rule says, right? But in higher dimensions, it at mean it would be a small blip. Uh, that means very minimal points lies in that region. Most of the points lies in the tail region of that ellipsoid. Okay, so that is one of the statements I want to put forward. And that's all for today. I think I don't want to take more time. I want to talk about singular value decomposition, but that does reduce the mathematical calculations, but nothing much more than that. So I'll take that up in the um, next session, but maybe from next Saturday we can start with classification. Yeah, yeah, that's all for today.